Our program can be run using a simple GUI initialized from the command line. This layout emphasizes the modular design of the project and allows for more precise user control and troubleshooting. For this demo, we can simply run from the top to bottom of this interface to see all of the abilities of this tool. Using the standard Nmap scan tool, we can input a single IP address, a range of IPs, or a comma-separated list of specific IPs to scan. This scan may take a few minutes depending on the size of the network. The process of the scan and all subsequent actions can be tracked in the console window. When the scan is completed, all data is set to the database and the tool is ready for additional commands. Once the database contains all scanned data, the tool will build the graph into nodes and edges. This process takes some time as it loops through each item in the raw scan data. The console output indicates the current status of this process. It begins by creating a host node for each device scanned by Nmap, assigning a numerical ID and type H to indicate host node. Following this, the algorithm loops through the scan data to identify new attribute values. If the attribute has not been added to the database before, a new document in the attribute collection is created. Then an A-type node is added to the nodes collection. If the attribute node already exists, or after one was just created, we create an edge from the host node to the attribute node. This process is repeated until all required edges are connected. At the end of this process, the graph exists in the form of a list of edges containing a source, a destination, and an edge weight. Construct edge list records this list, currently in the Mongo database, into a local text file. Training sends this edge list to the GEM program for graph embedding. This example uses SDNE, which opens into an interactive MATLAB figure. Once we have this, we can calculate elbow values based on this graph, which creates a simple curve. The user can then decide what would be the most appropriate k-value for k-means clustering. This would be approximately where the slope of this graph levels out. For this example, we chose k equals 2. We then enter this value and generate clusters. As desired, the program indicates 2 clusters by color and provides a centroid for each. We can also try different k-values to view different cluster patterns. This then generates new groups and new centers. This can be retried to find the best fitting cluster for any given graph. As you can see in this demo, the second clustering provides 4 centers and 4 clusters. This data can then be analyzed as discussed in our presentation.